Welcome back to Jackson Square. Today we're going to be looking at multiplying fractions. Our objective for the day is I can use area models to develop an understanding of the concept of multiplying fractions. We've seen area models before. We call it the box method when we're multiplying whole numbers or multiplying decimals, but it's the same concept of how you're boxing it in and making specific areas for your quantities. So we're going to jump right in and we're going to look at how would we demonstrate using area models with multiplying fractions. So first, we're going to start with two of our own models that we're going to do by hand. And it says practice with models, model 2/3 of 1/4. Model 2/3 of 1/4. So the way that it's written, it makes me believe that the problem is 1/4 times 2/3. Because when you're multiplying something times a fraction, you're taking a part of something. So we want to know what would 2/3 of 1/4 look like. So that is what we would model. And I wrote it that way because of the wording. Model 2/3 of 1/4. Does it matter the order? Actually, it doesn't matter because multiplication is commutative. That means that the numbers can be switched around and the product or the answer would still be the same. But because of the way it's worded, it makes a difference for me. Probably not for you. And like I said, it's commutative property, which you'll learn later in the year. And you can switch the order around for multiplication and addition. Those are both commutative properties. So when we are modeling, just a rule of thumb that I like to do with my students to keep us organized is I always like the first number to be our rows, and I like the second number to be our columns. So I'm going to just put an R here and a C here. Hopefully you know that rows go left to right and columns go up and down. So our first fraction is going to be our rows and our second is going to be our columns. If you remember from the video on improper fractions, the denominator tells us how many rows we should have. So since my fraction is 1/4 or 1/4, I'm going to have 4 rows. So the first thing I would do is create 4 rows, trying to make them as even as possible, but we know when it's hand drawn, it's not going to be perfect, right? So 1, 2, 3, 4. So the first fraction is 1/4. So because it's 1/4, I'm going to shade one of these 4. So whichever one you would like to shade, I'm just going to shade the middle one. And I'm not going to shade it. I'm actually going to do some diagonal lines, which you'll see why in a second. If you don't have colors, like I have colors, and the diagonal lines are always helpful to show the difference. So then my second fraction is 2/3, and these are our columns. They're going to go up and down. So again, my denominator tells me 3, so I need 3 columns. So I'm going to make 1, 2, 3. And of these, how many would be shaded? 2 out of the 3 would be shaded. So if I'm shading, I'm going to do some diagonal lines the opposite direction for these to represent my shading. So when we're looking for our answer for this problem, what is 2/3 of 1/4? 2/3 of 1/4, we will be able to find our answer by the boxes that have overlapping shading. So how many boxes have blue and orange? The boxes that have blue and orange would be 2. See how this one has blue and this one has orange? The lines are overlapping. Those 2 would be our numerator. Then our denominator is how many total boxes do we have? So if we're counting total boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12. So what is 2/3 of 1/4? It's actually 2/12. 2 out of 12. 2 out of 12 of these boxes are shaded with the orange and the blue, or have the little X's with the orange and the blue. So this is how we would do an area model to show how the concept of multiplying fractions looks. Okay, so 1/4 times 2/3 will give us a product of 2/12. And if you want to visually see what is 2/3 of 1/4, you will see that 2 out of 12 have the same two colors. Okay, so the next one, I'm going to shade them so you kind of see the difference. It helps if you can see that difference. Trying to see if I can pick two light colors. Okay, so the next one says, what is 2/3 of 1/2? Or model 1/2 of 2/3. So what is 1/2 of 2/3? So this one has 2/3 in the front times 1/2. Again, the order doesn't matter. It would turn out the same way. Again, 2/3, since it's in the front, it's going to be my rows, which go left to right. And 1/2 will be my columns, which go up and down. So because I have 2/3, 2/3 rows means I'm going to have 3 rows. So let's make 3 rows. And of those 3 rows, 2 out of 3 of them are shaded. That's what 2/3 means. So I'm going to shade these with this nice neon color. And I'm just going to shade the top and the bottom one for artistic vision. Then what is 1/2 of? So because the second fraction is 1/2, that means I'm going to have 2 columns. So I'm going to split this. And now I have 2 columns. And of those 2 columns, 1 out of 2 is shaded. So if I was going to go and shade, I'm going to just shade these on my left. And this whole side would be shaded. And I was kind of hoping that it would make a greeny color with the overlapping ones. You can see that it's darker. It's a little bit darker with those two. So the 2 that are overlapping is our numerator, and our denominator is how many total boxes. So what is 1/2 of 2/3? How many boxes have both colors? This box has both colors and this box has both colors. So the answer would be 2. And then how many total boxes do I have? 3, 4, 5, 6. So 2, 6, right? 2 out of 6 have the shaded. So what is 1/2 of 2/3? 1/2 of 2/3 is 2, 6. Okay. And let's remember from our estimating products, whenever we multiply a piece by a piece, our answer is going to be what? A crumb. So let's go back to the first one. 2/12 is definitely smaller than 1/4, and 2/12 is definitely smaller than 2/3. And 2/6 can be simplified if you know how to simplify fractions. It will be 1/3. Yeah, which is less than 2/3 and less than 1/2. So anytime you multiply a piece times a piece, your answer or your product is going to be a crumb. So you guys should have imagined in your head that it was going to be a smaller portion of the whole thing. So looking at the whole picture, it's a crumb in comparison. That's how I think of it. Okay. So I'm going to show you how to model these, of course, with another method. If you're not doing it by hand, I have a tool that I can show you, and hopefully you noticed and you remember how to multiply fractions. So when we're multiplying fractions, it's super easy. You multiply numerator times numerator and denominator times denominator. So 1 times 2 is 2, 4 times 3 is 12, gets 2 12s, right? So we're killing two birds with one stone. You can physically see why that answer is true, and you can do the algorithm by multiplying the numerators together and the denominators together and getting your answer. All right, so here's a cool tool that we can use to help us show models when multiplying. So I'm going to practice with a couple of problems so you guys can see it. So let's jump in and try 3/5 and watch how it's changing as I'm changing the numbers, and 2/3. So I have 3 out of 5 shaded in red and 2 out of 3 in blue. Hopefully you remember your color wheel, that red and blue is going to make purple. And the ones that are overlapping are purple. So the overlap is 6 out of 15. There are 6 that are overlapping and there are 15 total boxes. This fraction can be reduced. If I reduced it by the GCF of 3, I would end up with 2/5, which if I took these and I combined them, yeah, if they were combined, this, I could take this bar and put it there, and this bar and put it there, and then 2 out of 5 would be shaded. Let's model another one. What if I wanted to multiply 4/9 times 3/8? And watch how the model's changing. So the numerator, again, like you learned in elementary school, is the ones that are shaded, 4 out of 9. 9 is how many total. That's how it's divided. And 3/8. What would I get if I combine 4/9 and 3/8? I would get 12 70 seconds, 70 something. 12 out of 72. And this can be simplified. The GCF would be maybe 6. I'm going to go with 6. I don't know off the top of my head. I'm going to go with 6. And I am wrong. The GCF clearly must be 12. So the GCF would be 12. So if we took all these purple boxes, if I took this row and stacked it here, then 1 out of 6 would be shaded. So just show that again, how they took the 72 and they simplified that. It's the same space, but it just looks differently. So 1 out of 6. Let's try one more. And you will have access to this tool, so you can definitely play around with it or use it to help you with your problems. You will have a link. 4 7s times 1 6. Just to see how this looks. So we have 4 7s times 1 6. We're going to multiply these and they're going to combine. Awesome. That's so cool. So I would have 4 out of 42. 4 out of 42. I'm going to say the GCF is 2 this time. Let's see if I'm right. Yes, I am. So if I took these and combined them, I would have 2 boxes shaded. So if I took this one and moved it there, and this one and moved it there, 2 out of 21 boxes would be shaded. Oh, I can move them. See, stuff that you learn. I could have been doing that. How cool is that? All right, so 2 out of 21 would be shaded. Yay. Okay, now that I know how to do this, I want to go back and do it to another one. So let's go back and do the last problem, and then I'm going to end this video so you guys can get to work and stuff, right? So let's do this one again. So 12 out of 72, and it becomes 1 6, and I can move this, and that is awesome. So I can show you that it would be 1 out of 6 shaded with a different version of the grid. So I hope that you found this video enjoyable, and I hope that you look forward to practicing with this tool yourself and some other applications and methods that we have for you guys. Good luck.